Okay, guys, you're on your own today and you're going to be reviewing. But just to give you some reminders of some important things, I want to show you something we talked about in 1-1. When we see something like this is equal to this right here. Now, pay attention. Look at the order of the 3 times x times y. Did that change? 3 times x times y. Notice the order stayed the same. The only thing that happened was these parentheses moved to a different location over here. When you see that happen, that is going to be the associative property. And since what's happening, sorry, not here, what's happening right here is a multiply, then it's the associative property of multiplication. Now I want you to notice that on the left side we have 3 plus x, but then when we come over here, those two things flip places. Anytime you see objects flipping places like this, we're going to have the commutative property. Now, with commutative property, you need to look at the things being flipped. So obviously, the things being flipped are the x and the 3, and then look between them. What do we have? It's an addition sign, therefore it's commutative property of addition. I really want to warn you about this one. Again, pay attention to what is happening. The only thing that changes between the left side and the right side are these two things here. And what you should notice is that 2 times x becomes x times 2. Now, obviously, those two things are the same. So, we know it's commutative because something is flipping. Now let me once again draw your attention to what exactly is flipping. It's the 2 times the x that becomes x times 2. Can focus on what it is that's flipping and then look at what's happening to the things that are being flipped. They are being multiplied, so therefore this is the commutative property of multiplication. Don't be distracted by this plus sign right here. Quick 1-2 review. When we're evaluating expressions, let's make sure we don't get lazy here. Take this expression right here and plug in exactly as you see the values that are given to you. So the absolute value of z, I'm going to rewrite that as the absolute value of, well, they told you z was 3, so that's here, minus y, so that's minus this value of y, which is 2, minus, now we're working on this. I'm writing it exactly as I see it. So there's a parentheses, an absolute value, and then it says x. So I'm going to put that -1 in there, close the absolute value, minus the z, which we know is 3. At this point, we can go in and simplify everything. You should know that absolute value of 3 is just 3, minus 2, minus, now before we do anything here, let's figure out what is going on here. So inside this parenthesis we have the absolute value of -1, which is 1, minus 3. Okay, again we have to start over here because PEMDAS tells us to work on the parentheses. So that's going to be 1 minus 3, which is -2. So then we have 3 minus 2 minus -2. And you will recall that when we have two negatives next to each other like this, that we have to turn that into a positive. So that becomes 3 minus 2 plus 2. And that simplifies to 3. So now we have combining like terms. So let's look for some like terms. We've got an x squared here. Well, 4 of them actually. Now, just be careful because here we have 3x squared, but it's actually negative 3x squared. If we've got 4x squareds minus 3x squareds, that leaves us with 1x squared. So we've dealt with that and that. Let's see what else we have that's like terms. We have a negative 2x and a positive 3x, which adds up to plus 1x. So we've dealt with that and that. What else do we have? It looks like we have a positive 5y and a positive 3y, so that's 8y's. and dealt with that and that. So that leaves us with negative z. Now, I personally would take away these 1s because you don't need that. It's just x squared plus x. And that's our final. I want to remind you how the distributive property works. In general, distributive property looks something like this. Right? Let's say that's, I don't know, a 4. And you just have to distribute by multiplying that 3 to both of these terms. So that would be 3x plus 12. Most of you should be okay with that. So let's get rid of this. In this problem here, we did this in class, you will recall. This right here is the same as saying x plus 7 multiplied by x plus 7. That's what it means to square. And the method I told you was probably the easiest that you may have been shown before was the box method. And, whoa, what just happened there? That's not good. Let's put that like there. Okay, so, so here's a box. Since we have x plus 7 here, we put x plus 7 there. And this one is another x plus 7. And now we just fill in each of these squares. This one is x times x, which is x squared. This one is 7 times x. So that's 7x. This one is also 7x. And this one is 7 times 7, which is 49. Then we just come in here and say, all right, well, that is x squared plus 7x plus another 7x, which is 14x. And then we've got finally 49. So that is how we use the box method instead of FOIL. FOIL was the first, outer, inner, last, but I think it's easy using FOIL. Now, the thing that gets tricky here is if I give you a problem like, let's say 3 times x plus 7 squared. Now you've got, excuse me, lots of work to do. But here's the thing. A second ago, didn't we just say that x plus 7 squared ended up being all of this? So if they ask you to deal with this right here, we can simply rewrite what we have there with that 3. And instead of writing x plus 7 squared, we're going to put this in there because this is the same thing. So that's x squared plus 14x plus 49. And then you just distribute the 3 times each of those things. I'm not going to finish that problem. Next up is one-step equations. I always like to kind of draw a line through the equal sign so that we know that if we do something to the left, we have to do the same to the right. In this case, when I say solve for x, what I mean is get this x on its own. Well, right now it's not on its own. It's got a 10 there. How do we get rid of 10? Most of you know already, you just subtract 10. Now, if I do that to the right, don't I also have to do it here? And when we balance everything out, they cancel out. We've got an x here, and 17 minus 10 is 7. There's your answer. Very simple. Let's try a two-step equation. That was 1-6, so let's come up with something like, I don't know, 2x plus, no, I'm going to do minus 7 equals 21. Okay, bring down our line, and we want to get the x on its own. So we want to isolate this. So let's start by getting rid of the negative 7. The opposite of negative 7 would be positive 7, but if I do that on the left, got to do it on the right also. Let's see what's left. They disappear. We're left, we bring down that 2x. Still got my equal sign. And then 21 plus 7 is 28. Now here, to solve for x, we've got to get rid of the 2. This is 2 times x. So the opposite of multiplying by 2 would be to divide by 2. So divide that side by 2 also, and we end up with x equals 14.